Hello, welcome to PhyzQuest. So this is the solution video for GATE 2020 Physics question number 9. The question is, a medium with epsilon r greater than 0, mu r equal to 1 and sigma greater than 0 is semi-transparent to an electromagnetic wave when the conduction current is much greater than the displacement current, or the conduction current is very less than the displacement current, or the conduction current is equal to the displacement current, or both the conduction current and the displacement current are 0. So we have to choose the correct option here. So let's get started. So this question comes from the section Electromagnetic Theory, and the concept involved here is the displacement current. So first of all, you must understand the difference between the conduction current and the displacement current. For that, best would be to consider a circuit with a capacitor and an AC source. So conduction current is the current due to the flow of electron through the conductor due to steady electric field. Now displacement current, here we have a parallel plate capacitor. Initially there is no current. Now when the capacitor is connected to the power source, so the plates of the capacitor starts to charge, and here the charges will start to accumulate on the plate. One side there will be positive charge and other side there will be negative charges. So due to this, there will be an electric field is created due to this factor. So since this is an AC source, so because of AC source there will be it has a positive half cycle and a negative half cycle. So therefore the charges on the plate will change in every cycle. Due to this, there will be change in the electric field between the plates, and due to this change in electric field, it will induce the displacement current. So displacement current, the definition is the current produced due to the change of the electric field. Now in this case, the parallel plate capacitor, here there is no medium, it's a vacuum is in between them. Now suppose there is a material is placed in between the plates. So what will happen here is, when the power source is connected here, the atoms of this material will be affected. So what will happen is, here the atoms of the material, because of the power supply, what will happen is the atom of the material, the electrons of the atoms will deviate towards one direction, and the positive nuclei will displace towards another direction. So because of this creates an additional displacement, and due to this factor, displacement current increases. Now this depends upon the type of material used between the plates of the capacitor. So that means, what is the medium? So here, and that will actually, the type of medium placed will affect the displacement current. Now there can be three types of medium, that is transparent, semi-transparent or translucent, and third is opaque. Now transparent medium is the medium which allows the light to pass through it. Semi-transparent or translucent medium is the medium that allows a fraction of light to pass through it, and opaque is the medium which does not allow the light to pass through it. So the behavior of the displacement current will depend upon the type of the material used as a media. Now in the question, we have a semi-transparent medium with the relative permittivity greater than 1, relative permeability equal to 1, and the conductivity greater than 0. Now let us suppose the electromagnetic wave is passing through the medium. So let us suppose here we have the electric field equation for the electromagnetic wave is E equal to E0 cos omega t. Now the expression of the conduction current is conduction current density is Jc is equal to sigma E, which is equal to sigma E0 cos omega t. Similarly, the expression of displacement current density is JD is epsilon del E by del T, which is equal to minus omega E epsilon omega E 0 epsilon sine omega T. Now to find out which of the current will be higher, we have to take the ratio of the two current densities. So the ratio between the two current density will be, what we'll do is we'll take the modulus of both the terms. So modulus of JC by modulus of JD will be equal to, now here what we will do is, in place of omega t we will put certain values. That let us take omega t equal to pi by 4. So here both cos omega t and sin omega t will have a equal value. So that means they will actually cancel each other when we take the ratio. So ultimately at that scenario, modulus of JC by modulus of JD will be equal to sigma E0 by omega epsilon E0, which is equal to sigma by omega epsilon. Now from this expression, what we can interpret? See, it is given that we have a semi-transparent medium. Now what is transparency? See, transparent material, see what have happened is in material science, transparency means in case of a transparent material, light will pass through it without any absorption. That means light or the electromagnetic wave does not interact with the medium where it is passing through. Now semi-transparent material means a fraction of the electromagnetic wave can interact with the medium. So semi-transparent medium, when we consider, that means we can say when fraction of light is interacting with the medium, that means it is a poor conductor. So poor conductor means sigma is very less than omega epsilon. So that means the ratio, this modulus of JC by modulus of JD, which is equal to sigma by omega epsilon, will be very less than 1. That means we can say that JC is very less than JD, or we can say that conduction current is much less than the displacement current. Now let's check the option. As you can see here, if you look at the option B is matching with our result. So correct answer for this question is option B.